So today we're going to talk about lambda expressions in C++, but before diving into some very simple code examples, let's talk a little bit about philosophical aspects or the general idea of lambda expressions. So the idea already existed in other programming languages such as Java with the concept of inner classes, or Python, or probably many other functional programming languages such as Haskell, which they gave you the opportunity to sort of, whether you are inside a function or whether you're writing an expression, on the fly, you could write some anonymous or unnamed functions which provide you some simple functionality. So this was the general idea. Of course, it was very interesting, and it wanted to be sort of ported to and adapted to into the context of C++. And to the description of this video, I'll also add the paper which Bjarne co-authored with some other people, I think in 2006, and they basically talk about this addition of notion of lambda expressions or closures in C++. So now the question is, before the notion of lambda expressions, couldn't we achieve the same thing that lambda expressions are basically doing? And the answer is absolutely yes. So you could achieve the same functionality with sort of function object classes, which we're going to see in a second. And but you're going to see that there is an element of convenience with lambda expressions. So as I said, probably I didn't mention this, that lambda expressions were also part of C++11 a standard, or part of the modern C++ basically. And they are more or less pretty much very similar to function objects, in the sense that, function objects, function gives you the notion of some functionality, and objects give you the notion of classes, user-defined data types, which they can carry basically two things. They can carry information or data with data members, and they can carry functionality with member functions or methods. So lambda expressions are more or less the same. So they have the notion of functionality, but they have also the notion of objects. So they can also carry information. They can have access to sort of variables in the scope that they are being defined in. So let's say, without further ado, let's jump into some very simple examples. Right now I have my main.cpp here. Let's say I want to define a vector of integers. I want to call it as vec, and I want to initialize it with, 1, 3, 6, 8, 12, 31, and 42. So let's say I want to pass in this vector to an algorithm in a standard library, and I want to figure out how many of these, or which elements in my vector are sort of even numbers. So I can use for each for that. So let's say for each, and then I say vec.begin, vec.end, and let's say the functionality I want is something like find even, something like that. Right now, of course, Clang is complaining about vector because probably we haven't included vector here, and find even because we haven't defined anything for this one. So let's add the header files. So we're going to add vector, and we're going to add algorithm for each. Whoops. So now I'm going to define a class called find even. And I'm going to define it in a way that I just want to overload the call function operator. So what I want to do is void operator. And this is the call function operator. And I want to get a value, this is an integer. And all I want to do is to if value modulo 2 is equal to 0, so I want you to std cout sort of value. Yeah, and I can also put a space maybe as a delimiter. So I have a class find even, and I overloaded the call function operator. Now you see that Clang is all of a sudden happy that you can pass around this as an object, and then it will perform this thing. So let's see if it works. if I compile this and I run it, you see that it gives me 6, 8, 12, and 42. Whoops. And indeed, 6, 8, 12, and 42 are the even numbers in my sequence. So this is how you conventionally, or let's say how you traditionally could do, could achieve this thing with the notion of functional objects. So we could achieve the same thing with lambda expressions. So I can write this thing. Actually, I can copy that. So the only thing I need to change is this thing here. Let's say here's the notion of lambda expressions. You put a series of these brackets, and then you have parentheses, and then you have curly braces. So we're going to talk about each one of these. So the first two brackets, opening and closing, is basically gives you the capture mode. So if you need any variable from this scope, from the main function, basically, so you can pass it in if you need it in the lambda expression. You can pass it in. Right now, we don't need anything, but inside this parentheses, you're gonna put basically the input arguments. Let's say int value, just similar to overloaded operator call function. So, and the functionality is going to be more or less also the same. So I can basically jump up here and copy and paste everything to this thing here. So let's do this, and we pasted it, and we can do this and pass this one here. So we can achieve the same thing, but before doing that, maybe I should put an end line so that these two results are not on top of each other. So if I compile this and I run this, and you see that now I have the same sort of functionality, but take a look at here. So here's the element of convenience that I was talking about. So with the function object, you have to define sort of a class always. So the syntax looks good, but you have to define this class. And right now, we are just having just a simple functionality. Sometimes you just need information from main, which you need to pass into this basically class, and you need to construct this. And there is an element of inconvenience that you need to write these things. And besides, lambda expressions, as we said, the philosophy is that you are going to use some stuff on the fly. So this means that probably like you're going to use it at that specific local place. You want to use this functionality. Maybe somewhere else, and in other places of your code, you don't want that functionality at all. So this is the main idea of lambda expressions. So of course, in this case, because it's quite simple, it's just a functionality, we can achieve the same sort of thing with function pointers or with functions as well. So all I need to do is to just copy everything here, and I can paste it here, and I can, of course, remove all these spaces. And what I can do is I can name this function as, for example, even. I remove these things, and this is gonna, the body is gonna exactly remain the same. And what I'm gonna do is copy this thing, and probably I'm gonna copy this thing as well. And I want to pass the ampersand even. So I want to pass the address of sort of this function. So let's see whether this one works. If I compile it and run it, you see that the same effect happens with function pointers as well. But one problem with function pointers is that with function pointers or functions in general, you don't have a state, sort of. You can't carry sort of information. You can do some functionality, but you can't carry information. What I mean by that, let's say in this context, I wanted to, for example, print the index of the occurrences of those even numbers in my vector. So if I wanted to do that with my lambda expression, I could do, for example, a size team sort of index, and I initialize it with value of 0. And here is what I said capture mode. I can send this thing by send index by reference. And then what I could do here, I could come down here, and in my if statement, I'm going to say, let's do index plus plus. And probably here, I'm going to say also a vec and then opening and probably is not a space, maybe this thing. And then we could do index. And then we could close this thing. And then probably with a space and an equal sign and another space. And then we could do value. And we can put a simple s.end line here. So, and in the else statement, of course, I could also do this index plus plus. So now I can basically print the index. So I have the notion of information, the information that I could take from the scope that I defined this lambda function, which is inside the main. So if I compile this thing and I run it, you see that now I have very beautifully like the index. The second index is going to be 6. The third index is going to be 8. The sixth index is going to be 42. The same way, you could also achieve the same thing with function objects as well. So this is a very simple use case of lambda expressions, of course. And we have seen sort of the comparison of doing the same thing with function objects. And you could see the inconvenience of writing, always defining a class for it. Sometimes you need information from outside, and you need to have a constructor for this one. And, it's a hassle. And with functions or function pointers, you could also achieve the same thing, but they don't have sort of the notion of carrying information, let's say. So as I said, you should not misuse lambda expressions for heavy tasks because the philosophy and the idea of lambda expressions was basically to be carrying very simple operations. And the reason for that is most of the times also the compiler tries to inline the functions, which are the functionality which comes inside the lambda expression. And it should be able to do that. So you don't want to put heavy load of stuff inside your lambda expressions. So, yeah, that's pretty much it for today. I hope you learned something from this video and hope to see you in the next one.